So in this video, we're going to look at a new way of doing derivatives, and that's implicit differentiation. So it's still going to use all the tools that we used before: product rules, quotient rules, power rules, all that stuff, just doing it in a slightly different way. All right, so the first thing we're going to look at is what is an implicit equation. So we all know what we're talking about. We're talking about implicit derivatives later. All right, so a normal function, that's a relationship where you put in one x value and you're going to get a single output, so just one single y. And one thing with a function is they all pass the vertical line test. Right, so if I draw a vertical line, my graph is only going to hit each of those vertical lines once. Right, but not every relationship is a function. All right, I could have this relationship that looks like this, but it's not a function because it passes this vertical line 3 times. All right, so not every relationship is actually a function. So an implicit equation is not necessarily a function, but it's one that can't normally be solved for y. So it's going to have the x's and y's kind of mixed together instead of seeing it always in that kind of y equals format we're used to with functions. So here are some examples. And x squared plus y squared equals 25. All right, solving this for y would give you this kind of plus or minus, so it's not a function. And if you were to graph this equation, you're going to get a circle, which is not a function. So there's no way to write this as y equals. So doing it as an implicit derivative is kind of our only option. Right here, there's kind of y's all over the place, so solving this for y would not be possible. All right, but this is still this implicit equation. And finally, here we have this kind of xy inside of a cosine. It's going to be really hard to solve that for y. All right, so we just have this implicit equation. All right, so implicit functions can have some funky graphs, right, because they're not, and I put implicit functions, that doesn't really make sense. Implicit equations, I can have some funky graphs because they aren't necessarily functions. So we can start getting things looping over. We can get circles, all these things we can't have with functions, we can have in an implicit equation. All right, but how do we figure out what the graph looks like? All right, a point xy is going to be on the graph of our function if it makes the equation true. All right, so let's look at a quick example. All right, so this is the graph of y cubed plus x cubed minus 3xy equals 0. And if I were to pick any of these points on this blue graph, it would make the equation true. So the simplest one is the one that's right there, 0, 0. And if I make y 0 and I make x 0, you can see the whole left-hand side becomes 0, the right-hand side 0, and this is a true equation, which means that dot should have been on my graph. All right, so that's the way it would do. All right, just try x and y values. If it makes the equation true, it's on your graph. If not, it's not on your graph. All right, and again, you can see how this is different than any type of graph you would see talking about a function because they have this loop-to-loop here, which is not possible with functions. All right, but with implicit equations, it is possible. All right, this is what we mean by an implicit equation. Just know that they're not necessarily functions. The y's and x's are mixed together a lot, and the graphs can be varied, much more varied than the other types of things we've looked at so far.